Hi friends, this is Shweta from Department of Artificial Intelligence and Data Science. Today we are going to see about flip-flops. It is a sequential circuit which generally samples its input and changes its output only at a particular instance of a time and not continuously. There are the four types of basic flip-flops, which is SR, JK, D and T. Let's enter into set and reset flip-flop. The simple flip-flop circuit has a set input and reset input. Once the outputs are established, the wiring of the circuit is maintained until S or R means set or reset go high or power is turned off. The two outputs are inverse of each other. This is the block diagram and the circuit of an SR flip-flop. This is the characteristic table of an SR flip-flop, which contains clock pulse and S and R as an input and present state and the next state as an output. This is the characteristic equation of an SR flip-flop, which is Q of T plus 1 is equal to S plus R dash of Q of T. This is the truth table of an SR flip-flop. Without delay, let's enter into a demo for a SR flip-flop. For this, we need two toggle switches and we need a clock pulse here. And we need a SR flip-flop here to explain the SR circuit flip-flop, and we need two output controls here. By using a label box, we can label those switches and then outputs with its flip-flop. SR flip-flop, and the first input is S and the second switch is R. The first output is Q and the second output is Q dash. Let's start giving connections for this. The first switch is connected with the first SR flip-flop here, and R is connected with this R, and the clock pulse is directly connected with this SR flip-flop. Now Q and Q dash is directly connected to the respective output terminals. Let's check it with the truth table. While we are getting all the outputs we need. S. Let's see JK flip-flop. JK flip-flop, the input condition of an J is equal to K is equal to 1 gives an output inverting the output state. However, the outputs are same when one tests the circuit particularly. This is the circuit diagram and the symbol of an JK flip-flop. The characteristics table, which contains JK as an input and the Q and Q dash as an output with the respective clock pulse. And this is the truth table of an JK flip-flop. The characteristic equation of an JK flip-flop is Q of T plus 1 is equal to JQ of T dash plus K dash of Q into T. This is how we get the characteristic equation of an JK flip-flop. Without delay, let's enter into a demo. For this we need a two toggle switches here, and we need a clock pulse, and then we need a JK flip-flop here to explain the JK flip-flop circuit, and then we need a two output controls here. So now we can connect the clock pulse directly with the JK flip-flop, and now connect the first switch with the J and the second switch with the K flip-flop. Now we need a high constant here and connect it with the following. Now we need a push button here with NOT gate, connect the push button with the NOT gate and directly connect it with the CLR. Now connect the Q with the first output and Q dash with the second output. Now push it. Yes. By applying the values of truth table, we can get the respective switches what we need. We are getting the values through the clock pulses. What are the truth table values we need here in the JK flip-flop circuit? So this is the simple demo of an JK flip-flop circuit. Now we can enter into an D flip-flop. D flip-flop is a better alternative that is very popular with the digital electronics. They are commonly used for counters and shift registers and as an input synchronization. This is the flip-flop diagram of an D flip-flop, and this is the symbol of an D flip-flop. The characteristic table which contains the clock pulse and the input and the output. And the equation of an D flip-flop is Q of T plus 1 is equal to D. This is the truth table of an D flip-flop. Now let's take a demo for this. For this we need two toggle switches here, and we need a clock pulse. For this we need an AND gate here, and we are going to explain a D flip-flop, and we need a push button here, and with NOT gate, and also we require a high constant here, and we need a two output controls. Now let's start giving connections for this. Connect the second switch and clock pulse with the AND gate, and the AND gate is directly connected with the D flip-flop, and now the first switch is directly connected with the D flip-flop. Now the high constant is connected with the flip-flop like this, and the push button generally connected with the NOT gate, and then it directly goes connected with the CLR. Now the outputs are directly connected with the output controls. Now push it. Yes. By using the truth table values, we can find whether the D flip-flop connections are correctly given here or not. So yes, we get what are the outputs we need for this. So this is the circuit demo of an D flip-flop. Now enter into an T flip-flop. A T flip-flop is like a JK flip-flop. This is basically a single input version of an JK flip-flop. This is the circuit diagram and the symbol of an T flip-flop. This is the characteristic table of an T flip-flop, which contains Q of T and Q of T plus 1. This is the characteristic equation of an T flip-flop, which is Q of T plus 1 is equal to T dash of Q of T plus T of Q T dash, which is simply Q of T plus 1 is equal to T XOR Q of T. This is the truth table of an T flip-flop, which we used in our demo. So before entering into a demo, the inputs are E and T and the outputs are Q and Q dash. Now enter into a demo. For this, we need a 2 toggle switches here, and we need a clock pulse, and we need a AND gate here, and also we need a push button connected with NOT gate. And now we are going to explain a T flip-flop. So we need a T flip-flop here, and we need a 2 output controls here. By using a label box, just label the input. The first input is T and the second input is E, and the first output is Q and the second output is Q dash. Let's start giving connections for this. Now E and clock pulse is connected with the AND gate, and the first switch is connected with the T flip-flop, and the AND gate's output is connected with the T flip-flop. Now the push button is connected with the NOT gate, the push button is directly connected with the NOT gate and also with the CLR. Now Q and Q dash is connected with the respective outputs. Here we also need a high constant, which is directly connected with the P. Now push it S. By using an input and output variables of an truth table, we can get the output we need. Here we are getting, when the T switch is on, we get the Q dash as an 1, and the enable is on and the Q is 1. So we get a required output which justifies the T flip-flop is the given connections are correct here. So thank you.